se ainda tem algum eco.
Ainda tem. Vê se você consegue tirar o tom do seu.
É só abaixar seu volume, talvez. Vamos testar de novo. Não, você não abaixou. Vê de onde está saindo. Você não é do celular?
Não é do celular. Não é do celular. Inclusive, já liguei.
Testando de novo. Agora parece que está sem eco.
Está sem eco agora?
Vocês estão me ouvindo bem agora sem eco? Ah, não. O eco apareceu de novo. Está vindo daí.
Aí ainda. Pode falar.
Tá, tem ainda. Por que não está desligado, hein? Tenta baixar o volume. Sabe o que você faz? Tenta colocar um fone de ouvido. Vê se melhor. Você tem algum aí?
Estou sem um fone de ouvido. Deixa eu vou trocar.
Deixa eu ver se eu tenho. Problemas técnicos. Testar de novo. Vamos ver se agora tem eco. Ah, parece que agora não tem mais. Eu tive que improvisar aqui. Eu coloquei um fone de ouvido aqui. Agora a gente está ouvindo aqui sem eco. Vocês estão ouvindo algum eco aí? Fabrício?
Aqui está perfeito, viu?
Ah, maravilha. E consegue? Minha voz está chegando bem aí, nítido.
Muito bem, bem claro.
Ah, maravilha. Desculpe aí, Fabrício, a gente estava com um eco aqui, a gente estava resolvendo. Tudo bem com você?
Tudo bem, professor. Satisfação.
Pois é, faz tempo, né, que a gente não conversa. Feliz de ver você de novo. Dessa vez, a gente está com o professor Ettore aqui também, tá? Eu não sei se eu viro a câmera aqui só para apresentar vocês. Eu tenho uns convidados também, a Gabi, aqui da nossa equipe de pesquisa, e o professor
Ettore, prazer.
O professor Ettore aqui da mecatrônica, né? Ele conhece bastante aí sobre o assunto, vai poder colaborar bastante com a gente. O professor Fabrício é lá do Senai, fez doutorado na mecânica ou na mecatrônica, Fabrício?
Foi na sistemas de potência aí na elétrica.
Ah, na elétrica, desculpa, né? Então também é prata da casa aí, né? E a gente já desenvolveu aí uns projetos.
Extensão.
Só um instantinho, Fabrício, que a gente está arrumando aqui uma extensão para o computador do professor Ettore.
Sem problema, professor.
Enquanto isso, se você tiver alguma dúvida, pode perguntar. Tá?
Não, tá tudo bem, professor.
Só lembrando, o Abba, né, é nigeriano, a língua principal dele aqui, né, para fazer essa pesquisa é o inglês. Então, a princípio, a apresentação, tanto o trabalho como a apresentação foram desenvolvidos em inglês.
Tudo bem.
Então, mas,
a gente fez a qualificação, né?
Tudo bem? Se tiver algum problema, a gente traduz aí, ou se tiver algum termo, alguma dúvida aí.
Você entende se a gente fizesse perguntas em português?
Eu acho que a maior parte entende, né, Abba? Mas aí qualquer coisa eu ajudo também.
Qualquer coisa. Eu tenho português, mas é só para falar. Mas eu vou entender, eu acho.
Tá bom. Bom,
a gente se ajuda. Não, o Abba acabou de falar. Quer ver? Abba, fala alguma coisa aí, só para ver se está chegando bem para o Fabrício.
Ele está ligando.
Você consegue ouvir o Abba, Fabrício? Senão,
Não, eu consigo.
gente...
Está um pouquinho mais baixo que o senhor, mas dá para ouvir.
Porque se for o caso, eu posso aproximar o meu computador do dele na hora que ele for apresentar, ou então ele liga o microfone dele e eu desligo o meu. É só porque se ficar os dois ligados, dá F.
A microfonia, perfeito.
Outra coisa, aproveitando enquanto o pessoal foi buscar uma extensão, enquanto isso, deixa eu só falar um pouco sobre os procedimentos, né? Para adiantar. Eu já imprimi uma folha, acho que já deixei aqui com você, né? Abba, vou mostrar para você, não sei se dá para ver aí, uma folha que, depois da apresentação, vocês vão avaliar, baseado no que vocês já analisaram, a necessidade de uma eventual necessidade, se vocês acharem adequado, de uma edição revisada. A gente normalmente faz isso, é muito comum aqui. Então, ele está totalmente, já conversei com ele, está totalmente de acordo em fazer a edição revisada, ele vai assinar aqui, conforme a necessidade, viu? Tá mostrando. O Héctor já deve conhecer esse papel, né? Se for o caso. Mas, de qualquer jeito, a gente sempre insiste aí que o pessoal revise os trabalhos independente do resultado, porque sempre tem coisa para melhorar, sempre tem coisa para aprender, né? O que mais que eu tinha para falar? Sim, no seu caso, Fabrício, eu te mandei por e-mail, mandei para todo mundo, né? Aquele outro documento, além desse daqui, né, que eu mandei também, eu mandei a ata da avaliação, né? Quem já está aqui pode assinar aqui mesmo, mas a minha sugestão é que você pode assinar e mandar por e-mail para a gente.
Sem problema.
Aí a gente imprime aqui, a gente assina aqui nela mesma para ficar a assinatura de todo mundo e a gente despacha por e-mail para o pessoal da secretaria. Acho que é tranquilo. Normalmente é esse o procedimento mesmo.
Tudo bem.
Não.
Você quer experimentar compartilhar a sua tela para ver como você vai fazer?
Não, é que estou usando esse computador, entendeu? Porque essa aqui estava dando aquele eco.
Tá, você vai usar isso.
Trocando, sim.
Tá, melhor. Que legal, foi você que... Obrigado, né? Tem uma previsão da gente fazer uma ida para lá, uma visita lá, né? Que vai ser legal também. Para o Mali, pro Mali. Eu pessoalmente não sei, não está previsto, mas o grupo sim. Aí algumas pessoas devem ir. O Carlos. Não, todos eles que estavam na visita hoje são de lá, do Mali. Para explicar. Em primeiro lugar, mais uma vez, obrigado. Antes de confirmar com o professor Héctor também. Professor Héctor, quando estiver ok, a gente começar. Mas fica à vontade aí. Veja se... Desculpem, primeiramente, aí os atrasos técnicos aí, como eram vários computadores, às vezes a gente tem algum probleminha na hora de conectar. Muito obrigado pela presença de vocês. Muito obrigado pela presença dos nossos convidados aqui também, e especialmente na nossa banca, o professor Héctor e o professor Fabrício. O Fabrício já conhece esse trabalho um pouco mais de tempo, inclusive na qualificação foi membro da qualificação também. E o professor Héctor é muito bem-vindo aí para agregar muito mais informação também. E para a gente aprender, é sempre um aprendizado para todos nós, né? Esse trabalho tem 2 orientadores, aproveitando para explicar. O professor Tomi não pode estar aqui agora, ele está recebendo uma delegação do exterior agora, como eu já expliquei informalmente, agora explicando mais formalmente, e eu estou aqui como o outro orientador do trabalho. Nós dois acompanhamos o trabalho muito de perto desde o início. O aluno, para não perdermos mais tempo, indo direto ao ponto, se ninguém tiver nenhuma pergunta, se tiver, por favor, façam. Mas só para explicar, o Abba, o candidato Abba tem em torno de 30 minutos, a gente costuma dar no máximo 40 minutos, né, para concluir. Eu acredito que, pelo que ele já ensaiou aqui, vai ser tranquilo não passar desse limite, né, Abba? E depois, cada membro da banca tem até 1 hora, conforme se sentir confortável, para fazer as arguições que julgar relevante. Deixa eu ver se tinha mais alguma coisa. Acho que os principais pontos são esses. Alguém tem alguma pergunta? Não? Então, a partir de agora, a palavra está com você. Por favor, pode começar.
Tá bom. Muito obrigado. Okay. Good afternoon to you all. My name is Abdullahi Abba Dalhatu, and I'm here to present to you my master's dissertation titled An Investigation of Inspections by Remotely Operated Vehicles in the Offshore Oil and Gas Structures. Over the past few years, I have been conducting research in the field of remotely operated vehicle inspection, maintenance, and repairs. And today I'm excited to share with you my findings. But before that, I would like to thank my professors, Professor Giorgio de Tomi and Professor Ricardo, for their invaluable guidance and support throughout the course of this research. I would also like to thank Professor Ettori and Professor Fabrizio, who are the committee members, for being with us here today to evaluate my work. Thank you very much to everyone watching this presentation. This is my academic journey. I received my Bachelor of Engineering in Electrical and Electronics, majoring in communication from the University of East London in 2012. And in 2017, I got the scholarship award from the Petroleum Technology Development Fund in Nigeria, which brought me here to Brazil. And here in Brazil, I was opportunity to get a research grant from CNPq on the applications of remotely operated vehicles in shale oil and gas production. My first publication was in 2021, titled Recent Developments of Remotely Operated Vehicles in the Oil and Gas Industry. And it was published in a local journal here in Brazil, Polos. It is a Qualis Capes A3 paper. My second publication was in 2023, and it is titled Remotely Operated Vehicle Taxonomy and Emerging Methods of Inspection, Maintenance, and Repair Operations. It is published in an international journal, the Journal of Offshore Mechanics and Arctic Engineering. It is also a Qualis Capes A3 paper, and it was published in 2023. I was opportune to also participate as an alumni monitor in the mining project from the September to December 2022. This is the agenda of my presentation. I have 9 items. I have my introduction, my research questions, my methodology, and item 4, 5, and 6 addresses my research questions. And then I have my discussions, conclusions, and recommendations. The context of my investigation is to examine the use of remotely operated vehicles in the offshore oil and gas inspections, and explore the classification of remotely operated vehicles and the efficiency of the methods and techniques employed, including factors such as reliability, efficiency, and accuracy. It also includes the potential limitations or challenges. And the ultimate goal is to identify a better alternative to the traditional methods of conducting inspection operations. This is important because in the production of offshore oil and gas, inspections, maintenance are crucial for their safe and efficient operation. Traditionally, inspection operations have been carried out by human divers or manned submersibles, but advances in technology have created the possibility of using remotely operated vehicles to this end. The use of remotely operated vehicles have several advantages, such as reduced cost, access to difficult to reach areas, and safety of personnel. The main aim of the research is to enhance the overall comprehension of the ROV user community. My problem statement highlights the challenge of cost and the new technologies that are emerging to mitigate this challenge, and how these new technologies are blurring the previously accepted lines of demarcations differentiating remotely operated vehicles. This has created the need for a more sustainable classification taxonomy, and my research questions follow up on this by investigating the methods and techniques employed. The general objective of the research is to investigate, present, and describe the current state and future of ROV-based inspections in the offshore oil and gas industry. The first question is to investigate the techniques utilized in inspection of offshore assets, and the second question is to investigate the methods of conducting inspection operations, and the third question is to identify how these new technologies affect the classification of remotely operated vehicles. The methodology is an integrative literature review. It synthesizes information from multiple sources to create a comprehensive understanding of the topic. It differs from the traditional method of literature review, which typically summarize the findings of individual studies. And this methodology will enable us to address our research questions and make meaningful contribution to the field. Part one is the techniques used by remotely operated vehicles for inspections. And this part addresses the first research question. These are some of the existing current research that explore the use of non-destructive testing techniques for conducting inspections. Zhang et al. 2019 identified a trend towards integrating various types of sensors into a single device to detect multiple defects simultaneously. They also highlighted that the general visual inspection is the most commonly used approach for subsea production systems. Ho et al. 2020 discussed the development of automation and robotics, such as remotely operated vehicles, autonomous underwater vehicles, pipeline crawlers, and intelligent pigs, which provide cost-effective and accurate inspection of subsea pipelines. When it comes to inspection, there are three levels of inspection: general visual inspection, detailed visual inspection, and close visual inspections. There are 5 techniques utilized in conducting these inspections. We have the visual inspection, acoustic non-destructive testing, electrical non-destructive testing, electromagnetic non-destructive testing, and the multi-inspection non-destructive testing. Under these techniques, there are several techniques that are used, out of which we have chosen the 6 popular underwater non-destructive testing techniques for our qualitative comparison. Inspection techniques can be divided into contact and non-contact. Under the contact, we have the pod-based inspection technique and the manipulator-based inspection technique. Under the non-contact, we have the visual and the 3D reconstruction inspection technique. By the down left image, we can see an example of a 3D reconstruction inspection technique. It's an image of a side scan sonar showing the faults in an underwater pipeline. And this is an image of a remotely operated vehicle applying the alternating current field measurement using the manipulator. It is the part of the manipulator-based inspection technique. And then the manipulator-based inspection techniques.
Sorry, I think I should close this. Better to see.
Okay, thank you. The manipulator-based inspection technique suffers from stability and dexterity challenges, and that is why the pod-based tools were developed for inspection. This is an example of a subsea pipeline crawler, which is a pod-based inspection tool. We have, as I have said earlier, we have chosen 6 of the popular underwater NDT techniques, non-destructive testing techniques, which is the alternating current field measurement, the magnetic particle inspection, the eddy current testing, the ultrasonic testing, the radiographic testing, and the acoustic emission testing. We have considered 5 factors for our comparison: detection promptness, accuracy, cost, and ease of usage. Based on the information in the literature, I rated each of the factors as high, low, or medium, represented by 1, 2, 3 respectively. And from here we can see that the ACFM, which is the alternating current field measurement, and the eddy current testing and the acoustic emission testing are the best inspection techniques. For the overall rating, a qualitative and quantitative comparison was used by assigning weights to each of the factors according to their importance. And also from here, we can see that the alternating current field measurement, the eddy current testing, and the acoustic emission testing are the best inspection techniques. Part 2 is the methods of remotely operated vehicle based inspections. And this part addresses my second research questions. These are some of the existing current literature that explore the methods of remotely operated vehicle-based inspections. Anderson 2018 presented a case study on the advantages and limitations of using unmanned surface vessels in conjunction with remotely operated vehicles. This approach has shown potential in reducing cost and improving safety in the subsea operations. Stevens 2019 argues that the resident vehicles can be practical solution to reduce cost and risk associated with frequent mobilizations and demobilizations of vessels and equipment. Bob 2015 and 19 reviewed underwater robots and concluded that the subsea residency and the other techniques can enhance the availability and capabilities of autonomous underwater vehicles and remotely operated vehicles while reducing operating costs. The research highlights growing interest in exploring alternative approaches to subsea operations and the potential benefits of integrating unmanned surface vessels and resident vehicles in subsea operations. These are the methods of conducting inspection operations. There are 5. In conduction of inspection operations, there are several parties involved. The license is the owner of the operations department, and it is they who hire the subsea contractor to perform the inspection operations, and the subsea contractor hires the support vessel from the vessel owner. And sometimes the oil companies hire third parties who are specialized service providers to be on the vessel together with the subsea contractor because of maintenance contracts of the equipment that they supplied. In the traditional method of conducting inspections, which can be seen here in the top left side, the support vessel usually transports the remotely operated vehicle along with the crew to the site, and the support vessel supplies power and communication to the remotely operated vehicle. The unmanned surface platform, which can be seen by the top left, is a miniature version of the traditional method. It has been called several things by several authors depending upon the type of support vessel being used. For example, some authors call it an autonomous underwater vehicle, remotely operated vehicle method, and some call it unmanned surface vessel, remotely operated vehicle. It all depends on the type of surface platform that they use. And for this, we have named it, at the end of the day, it is a support platform for the ROV. So we have defined it as an unmanned support platform. The resident remotely operated vehicle method can be seen at the below left image. It is a permanent installation offshore in the vicinity of the offshore assets, in the vicinity of the subsea assets, and it has docking stations that serves as shelters for the remotely operated vehicle. And these shelters, or docking stations rather, provide the ROV with communication and power. This method allows for continuous monitoring of the subsea asset, and it has eliminated the need for the support vessel entirely. The semi-resident ROV, which can be seen in this middle image, is a combination of the traditional remotely operated vehicle method and the resident remotely operated vehicle method. And it reduces costs by reducing the dependency of the support vessel. The DROV method is completely eliminates also, like the resident ROV, the need for the support vessel, and the ROV transports itself to the location. This is the qualitative comparison of the methods. As we did with the techniques, we have considered 4 factors for our comparison: technical capability, timeliness, cost, and piracy. And we have assigned weights to each of these factors to be able to represent visually on a bar chart the best method. And from here, we can see that the resident remotely operated vehicle is the best option for performing inspection of operations. And this is because it has the fastest response and high technical capability. Part 3 is the unresolved classifications. This addresses the 3rd research questions, and these are some of the current literature that explores the unresolved classification of ROVs. Jacobs 2017 argued that the propulsion methods determine the ROV classification, and that the problem of classifying ROVs remained unresolved. Kaposi et al. 2017 noted that there is no widely accepted classification for ROVs, making it difficult to compare and evaluate different models. And Hansen et al. 2021 pointed out that some literature use the term drone to refer to remotely operated vehicles, but it is rarely collectively applied. When it comes to ROV classification, we have to consider the 3 modes in which unmanned underwater vehicles operate. We have teleoperation, we have semi-autonomous, and we have autonomous operation. And generally, when the vehicle is teleoperated, it is called remotely operated vehicle, and when it is operated autonomously, it is called an autonomous underwater vehicle. And when it operates in both these modes, it is generally called a hybrid remotely operated vehicle. There are 4 schools of thoughts when it comes to ROV classification. The first school of thought believed that ROVs should not be classified, and that the classification should be abandoned entirely. And the second school of thought believed that the ROVs should be classified, but the classification needs frequent update. And the third school of thought believed that ROVs should be classified based on weight. And the fourth school of thought believed that ROVs should be classified based on purpose. This is the most popular classification that is used. For example, the main divide is between the inspection and intervention class. So we have inspection class ROVs and intervention class ROVs. ROVs generally have common components such as cameras, light, thrusters, and other sensors, common sensors. But they can also be differentiated by their uncommon components. For example, the working class ROV uses the hydraulic power to move its moving components. But because of the advancement in inspection tools, now heavy advanced inspection tools are being developed. Working class ROVs can find themselves in the inspection class ROVs. And in general, all types of ROVs can also be used for inspections. So these types of classification do not support modern developments. For example, here in the top left image, we can see a working class remotely operated vehicle performing a riser inspection. And this image right here is an image of a remotely operated vehicle that operates as a aquatic pedestrian, basically. And here it's an image of remotely operated vehicles with threads, and here is an image of towed remotely operated vehicle. For these reasons, we proposed a new ROV classification taxonomy that is sustainable with modern developments. And we considered all modes of communication, which is either tethered, untethered, or a combination of both, which is hybrid. And then we considered all frame types, which can be either open frame. For example, this is an open frame ROV, or closed frame, which can be in a form of closed frame like this, or like this, for example. And sometimes there are vehicles now that have a combination of both. They have closed frames that the ROVs operate like the normal shape of autonomous underwater vehicles, but then upon reaching the site, they transform into the normal box shape remotely operated vehicle. And we also considered all modes of locomotion in our taxonomy. Our research have evaluated the methods of inspections and the techniques of performing inspections. And we find that the alternating current field measurement, the eddy current testing, and the acoustic emission testing are the best non-destructive testing techniques based on an overall rating. And we have identified and categorized the emerging methods of conducting inspection operations, and which are the unmanned support platform, the resident remotely operated vehicle, the semi-resident remotely operated vehicle, and the drone remotely operated vehicle. And out of these, we find that the resident remotely operated vehicle is the best option for offshore inspection operations, and when used as a drone ROV, can eliminate the idle time and increase revenue. And our proposed remotely operated vehicle classification taxonomy considers all medium of communication, frame types, and locomotion types to encompass all possible variations rather of ROVs, and address the lack of a widely accepted classification. Our research has identified various techniques and various contact and non-contact techniques used in inspection operations offshore. There are different techniques available for inspecting offshore assets, and the effectiveness of each technique depends on factors such as asset type, environmental condition, and accessibility. The research also identified the different methods used to conduct inspection operations. There are 5 methods available for conducting inspection operations, and the most effective method depends on several factors, including type of asset, accessibility, environmental conditions. There are several identified new technologies that affect remotely operated vehicle classification, such as advances in automation, locomotion systems, communication systems, and advances in inspection tools. And the conclusion is that if accepted classification insists on using transitional parameters for the classification of ROVs, for the classification of ROVs, yes, the new technologies are likely to continue impacting the ROV classifications. These are our recommendations. Our investigation has shed new light on the current state and future prospect of ROV technology in the context of inspection operations, of course. Specifically, we recommend the adoption of the proposed sustainable ROV classification taxonomy, which provide a standardized framework for remotely operated vehicle categorization. We recommend fostering collaborations between the industry stakeholders and institutions to promote standardization. And we recommend investment in the adoption and development of the resident remotely operated vehicles for inspection, monitoring, and intervention operations. Our contributions to the field is the categorization and the evaluation of the emerging methods of conducting inspection operations using remotely operated vehicles, which can provide insight into the strengths and limitations of each method. And our proposed new ROV classification taxonomy that considers all possible variations of ROVs and uses non-transitional parameters to address the lack of a widely accepted classification system in the industry. These are some of the bibliographical references that I've used. Thank you very much for listening.
Thank you, Abba,
Yeah.
for your presentation.
Yeah.
Yes, you could stay under the 40 minutes, so
Okay.
that's okay. Now I think we can pass through the examiners. Usually we start with traditionally we start with the examiner that comes from the most distant position, which would be now Fabrício. So if you both agree, we can start with Fabrício. Fabrício, is it okay?
No problem, professor Ricardo. Acho que posso fazer em inglês, né? Eu fiz algumas anotações em inglês, acho que fica mais fácil para o Abba entender sem problemas.
Perfeito, eu vou aumentar aqui o volume para todo mundo escutar bem. Perfeito.
Então, eu vou ler as anotações. Se tiver alguma dúvida, estou à disposição. So first of all, I want to congratulate this board and the candidate. Thank you to Professor Ricardo Cabral for the invitation. Professor Ettore, it's a privilege to know you. It's a pleasure to collaborate with the team of the University of São Paulo. It's an institution where I also have studied and for which I'm very fond. About the work, I reiterate what I recommended.
Fabrício.
Sim, professor. Professor?
Uma caixinha de som. Será que tem lá no Napol? Lá no Napol, você sabe se tem? Ou eu peço aqui na secretaria? Do you know, Dixon, I should call the if they have...
It's better to call, the secretary, Will.
It's the highest level.
Yeah.
Can you see if there is another volume beside this one? Ah, maybe on the television?
The television does not have.
Where is the control of the television? Tem? Ah, okay. Maybe the television will. But we need to connect.
Yeah, it will not work.
I don't know to the cell phone. Can you open yours? Your sound, maybe your sound is higher, and then you close this.
Yeah, but it's going to keep interfering. Or maybe I don't know.
If I close mine,
Let me try.
Ah, okay, we have you.
Yes. I think he can talk on, I think. Professor Fabrizio.
Is it on?
Yes. Can you hear me?
Can you check?
Fabrizio, can you hear us?
Yes, loud and clear. Can you hear me? Hello? Testing, 1, 2.
Maybe we should.
Hello? Your sound is clear to me. Hello? Hello? 1, 2. Testing, 1, 2. Testing, 1, 2. Testing. Can you hear me? Testing, 1, 2. Testing. 1, 2. Testing. Hello? Vindo? Alô? Alô? Testando, 1, 2. Não ouço vocês. A imagem travou também. Agora a imagem está mexendo.
Não, a gente não está mexendo aqui.
Oi, professor. Eu desliguei minha imagem, vê se melhora.
A gente está ouvindo bem você.
Ah, é? Posso
Pode
iniciar,
continuar.
então? Então, vamos lá. Então, como eu disse, né, eu queria parabenizar aí. I want to congratulate this board and the candidate. Thanks to Professor Ricardo Cabral for the invitation. Professor Ettore, it's a privilege to know you. It's a pleasure to collaborate with the team of the University of São Paulo, an institution where I also have studied and for which I'm very fond. About the work, I reiterate that what I recommended on the candidates qualification board, the methodical organization of the options for carrying out inspection activities in offshore oil and gas structures by using ROVs is an excellent topic for the dissertation, and will certainly contribute to saving time and improving the decisions making of technology managers who work with this area. So congratulations for choosing this team. Regarding to the work, I would like to congratulate Abba for revising the version presented in the qualification. This new version is a much better structured and cohesive work. It's a very good improve that you made in relation of the previously work. This work is well fundamented and methodologic organized. So congratulations.
Thank you very much.
As I can see, what we recommended in the qualification board was well appropriated by the candidate. Okay, so you got the idea about the reference used are correlated, forming a basis for deducing conclusions about the position of the researched author. So you correlated the research that you have made that was a recommendation of the qualification board. This correlation allowed the elaboration of reference of the technologies related to remotely operated underwater vehicles and the spectrum methods provided by the use of these vehicles. So you can have the idea of how many methods we have by using ROVs. I will brief my recommendations because I think the work is already well revised. One of the suggestions I have is which it's not mandatory, it's only to make the work even better structured. It's the adoption of a list of abbreviations and acronyms. As there is only an index of figures, you don't have a list of abbreviations. There are many acronyms and abbreviations in the work that are inherent in the terminology of the topic addressed. It's typical of this area. You have ROV, USP, and etc. In this sense, looking for a more fluid reading of the work from the point in the text where the abbreviation of a term is defined, its full citation is no longer needed to perform it. As you put the acronym and the term in extension, after that, you can use only the acronym. In the work, you use the acronym, and after that, you continue to use the long term. You don't need to use the long term anymore, okay? I'm carrying out the most accurate spelling check of the work, but I haven't found anything relevant. I will undertake to send these notes if I find any detail that deserves attention in relation of this correction, okay? Finally, I want to congratulate Abba for his work and for his noticeable maturity increase as researcher. Until regarding your work, I had no idea about how many configurations or options to conduct inspections by using ROV exists. It's very surprising for me. So congratulations, Abba, for the work and your presentation. And my congrats to Professor Ricardo and Tomi too for the orientation of the candidates, okay?
Okay. Thank you very much, Professor Fabrício. And so I can turn the words to Professor Ettore.
Será que ele vai me escutar daqui?
A gente coloca o computador mais perto lá.
Eu não estou escutando bem, viu, professor?
Eu posso falar melhor? Posso falar ou não preciso?
A gente vamos testar de novo. Fala alguma coisa aí, Ettore, só para ver se...
Estão me escutando bem? Está escutando bem, Fabrício?
Estou escutando bem.
Maravilha.
É porque aqui eu tenho o PDF, eventualmente como um pedacinho dele, PDF da dissertação. Okay. Well, actually, I was prepared to. I wasn't prepared to do this interview in English, but I'll try. If I have any trouble, I will ask your help.
Thank you.
First of all, I thank you first of all for the invitation, and Ms. how can I?
Abdullahi.
Abdullahi.
Sim.
Mr. Abdullahi for this opportunity.
Thank you.
Well, I have no idea if this is the first time that this department has a research thesis on this field of ROV applications. So
I think so. I think it's the first time. Yes, we are starting this new line of research. Yeah.
So I congratulate also this initiative, because usually we are worried about developing the vehicles themselves and not so much worried about or concerned with the economical, technological trends on this field and how it will go in the future, and this in the applications that you have touched on. So it's important for us, for the developers, to have a broader view that I think your work tries to touch. So I congratulate in this case. Also, because usually in historical perspective, 1 or 2 decades ago, even now, I think it's not so usual in universities to do research or on ROV from the technological point of view. But sometimes you work with control of ROVs, some specific things, but not technologies to develop them. Because usually we are worried about AUVs. The team subject is that attracts more attention from the universities, are more related with AUV and sometimes hybrid vehicles, because you have the big challenge there. But of course, with time nowadays, as the world shows, there is a kind of confusion or some contribution between both fields, ROV and AUVs, because things applications are getting more complex. And that's why I think also universities are going to start maybe starting to work with this field as well. And my lab, particularly, we have developed an AUV, an ROV, and but usually we are not concerned with academic things related to ROV. Only, for example, we published recently a work on control on the wave effects of ROV. In this case, we get interested in this, in the ROV, but from the technological point of view, usually we develop in order to cooperate with companies and other institutions. Okay, so I congratulate the initiative to touch in this field and try to show us some perspectives of how this going the technological development in this case. Said this, before starting to make more detailed analysis, I'd like to know what is your main proposal in this field? do you work in this field,
Mm.
in the ROV or offshore industry? And how do you intend to proceed your career concerning to this subject?
Yeah, and well, as I said earlier, in my undergraduate program, I did electrical and electronics in engineering. So when I came here to Brazil to this department, mining and petroleum engineering, I had to choose something that is a little bit more closer to my undergraduate field. And this is the reason why I chose to perform my research on remotely operated vehicles, because when I was coming, they gave us a list of possibilities, and this was one of the possibilities. So this is the first reason why I chose this. And regarding my career on this, I would like to include that I seek to continue my PhD in this area of remotely operated vehicles, but with application in the mining, subsea mining application of remotely operated vehicles. Yeah.
So I understand that you have an electrical engineering background.
Yeah, I have. Yeah.
Well, so I hope that I can give some little help in order to improve, since you are going probably to also proceed, you intend to proceed in the PhD.
Yes.
Study. And if I compare, I took my PhD abroad. If I compare, especially master, in the case of masters, maybe here in Brazil, specifically University of São Paulo, and in the engineering course, we are a bit more strict sometimes about the text and the formality of the master thesis. And and of course, this will be the same in the case of the thesis.
Yes.
So I hope you take this as the comments as a contribution in order to improve your work. Okay.
Okay. Thank you.
I think I can make some global perspective comments, and afterwards talking about the papers.
Okay.
First of all, I think, as I told you, I like it, the fact that you touched in this subject, especially for the developers. It's kind of light that can orient us in the future. But I think, looking to your text, I would like to see a more structured work. Sometimes I see sections and chapters that mix subjects. Like, for example, you can separate the subject, for example, related with classification, taxonomy, and take it from there, the sections from 2.5 to 2.9 that are more related to the subsystems of the ROV. Maybe you could take out these sections and make a separate chapter. And you start with the broader chapter talking about classification, talking about AUVs, UUVs, and ROVs, and so on.
Yes.
You can assess that.
Okay. Thank you.
Although, I personally, I have also criticism about that. I would focus on some more important things in my view, more related with technology. What are the challenges and so on? And I think your work spends too much time discussing the correct taxonomy. I should call this an ROV, an AUV, a hybrid ROV, and so on. I can tell you, usually, if you're talking with a person from Petrobras, with other researchers, when I say ROV, everybody knows what I'm talking about. When you say AUVs, we also know what we are talking about. An ROV, if you tell me ROV, I think immediately, I think, oh, there is an umbilical cable. There is a vehicle that is remotely controlled. ROV by definition of this. The name is remote operated vehicle. So, and I think I see, I've seen a number of times a kind of conclusion about this. I know that you have published some works that have touched on this subject, discussing this.
Yes.
Maybe with evolution, as you mentioned, I think in your presentation, and there is in the text.
Yes.
The evolution of the technology, maybe this classification will be will change in the future and so on.
Yeah.
Okay. But for an engineer like me, and you are an engineer.
Yes.
Sometimes for me, this appears to be to discuss. In Portuguese, we say sexo dos anjos. The sex.
Yes.
And we should go. I would be happier if you were talking more deeply. What are the challenges to have a resident ROV? That is coming to be a common thing now, maybe. What are the challenges to have a drone, what we call a drone ROV?
Yes.
Because things that you mentioned in your text are not so trivial. How do you know any drone ROV?
Yes, they're
operating from a company.
Operating, no, but in development, yes. For example, there is one drone ROV from called the Aquanaut. Yeah.
Yeah, that was another question I had here.
Yeah.
Because I read only an article on IEEE Spectrum presenting this vehicle.
Okay.
Is it in operation? I think they launched that, but I don't know if there is any client who bought this vehicle and it's operating this vehicle.
That's right.
And how it will do. And I think I don't remember in the article if they said, okay, this vehicle can leave from the shore to the deep ocean directly.
Mm-hmm.
I haven't seen that because it didn't cross my mind.
Okay, I've seen it. They said that I think the maximum kilometers is 200 kilometers. It depends on, of course, some of the offshore assets are very deep, very far from the shore, and you can find some that are close to the shore. But I think they use powerful lithium batteries to be able to achieve this. Yeah.
Okay, but it doesn't. It's not these. Okay, this helps to go from the shore to the deep ocean.
Yes.
The fact that you have a big autonomy, but this is not all that assure that you can operate leading from the shore to the deep ocean. For example, you have in the 90s. No, it was in the beginning of this century. Mitsubishi company, they had developed an AUV with a closed system of combustion engine closed cycle, and it could go on with also fuel cells. It could it was kind of they reached a kind of world record about this the distance traveled by the more than this
Okay.
you mentioned. But even though it was a big vehicle that had to be launched from the ship
Okay.
and the mission. When you say, okay, a drone ROV that can fly, can leave from the land,
Yeah.
and go autonomously to the deep ocean. Well, to me as an engineer who had a bit of familiarity knowledge on this, it's a big challenge. And I don't know myself a vehicle like this that can leave the shore and go directly straight to the bigger, to the deep ocean. It's not only to have a autonomy.
Yes.
And it's not only this that
Yes.
you need for that.
Yeah.
Such kind of challenge. And so, when you say so, a drone ROV, you should present more data, I think, in your text showing this, how what they achieved in order to say that this thing is a reality. For example, I think there are maybe research on flying vehicles that afterwards they come and land in sea and become underwater vehicle. It's a big thing, and I think there are some research on this, but actually it's not popular at all.
Yeah.
And you can contribute to showing more detail this, and also the challenge and the analysis and discussions about that. Of course, not based only in your imagination, but based on what the researchers are doing, talking about this kind of challenge.
Okay.
So,
Okay.
in the global analysis, I would say that maybe this discussion about what is ROV, what is AUV, things like that, it's not so important. Of course, you can. Okay, let's use one of the criteria to classify, and let's say that in the future this kind of classification will have to change. Okay, that's okay, but I think I've seen too many times this kind of discussion that it was repeated along your textbook, and I would be happier to see more discussion, more explanations. For example, on the ROV market, the economical perspectives in the recent years, the challenge, the demand for this kind of vehicles. What kind of vehicles the market is looking for? Is inspection type ROV, working class ROV, and I agree with Professor Fabrizio about the problem with acronyms also. Sometimes, for example, this WCROV, I haven't seen a definition on that. There is a figure. Maybe I skipped that. I didn't see. I couldn't miss it. But okay, and there are times that you talk about the working class ROV, WCROV, and what is? I think it means working class ROV. Okay, but and you say a working class ROV using batteries. Again, if you're talking with me, with a person from Petrobras and so on, if you say working class ROV, we imagine what you show there. A big ROV, a huge ROV moved by hydraulic energy. And when you write working class ROV with batteries, well, okay. Because if you're talking about electrical type ROVs, you have it's difficult to classify them as working class because they don't have such a power by weight ratio so big as the common work class ROV. It's no you have to talk about them in this way.
Okay.
So I got an idea, but of course your supervisor had other ideas about how you could, for example, to construct a structure in your text to separate value things. For example, you have a chapter 4 is discussion.
Yes.
But for me, it was 2 or 3 pages, I don't know, 2 pages.
Yes.
And that thing you repeat. We are going in detail later on.
Okay.
Just giving you a broader view.
Okay.
And this discussion, it's not so deep. And just before, in chapter 3, you finish your chapter 3, making a comparison between the new technologies, resident, semi-resident, and so on.
Yeah.
Resuming that in a small
Table.
That's all. And afterwards, you go to a chapter, and you talk again a little bit about this comparison. And then you go to the conclusion, and again you repeat. So I thought first, take this discussion chapter, put inside the conclusions, what you call here sometimes final comments or final considerations. Considerações finais, não sei se essa tradução é correta. And there you don't put only your conclusions, but you have a space for a discussion, another discussion, and afterwards you put conclusion. And also one thing, I think you mentioned a little bit, and also we put a section on future steps of this research. Okay? So I felt examples of this, how the structure would be better organized. First of all, as I told you in the chapter, taking things from the chapter 2 and making perhaps another chapter on the technological features, characters of the ROVs, the subsystems of the ROVs. You talk about communication, energy, and things like that. And you could put also there inside or not a part dedicated to the applications where you can point as you can put as you did in your work here and there. And that was I think a good thing in the chapter, beginning of chapter 3 about applications.
Yeah.
This kind of non-destructive inspections and so on. Okay, so you give to the reader a broader ROV are made from these main subsystems, and afterwards the applications are related to these, because the master student, the master thesis usually is to show is to fill some blanks from your undergraduate background and puts all and to show the others. I have knowledge about this. I have a vision about this. I can discuss with anybody intellectually about this. So you show that, and also you, in your specific case, you can also educate them. As I told you, this is the first work in this subject here in the university. So you can, and if you can contribute it here, probably to majority of the Brazil universities would be use it for work as well. Yeah. For the people who wanted to work with ROVs, for example, or EUVs. Okay. So that's my first comment from the perspective of a global view of your text.
Okay, thank you very much for the comments.
Well, I don't know, but what think we think?
Bastante. Pode ficar à vontade.
Well,
a gente está dentro do...
In page 11, now I would like to comment and also to ask you about.
No.
Yeah. So maybe not so common to see this kind of approach, but if you go to another, of course, person knows it. Probably he suffered about that. He did his master and doctor. We are more kind of strict and more details and things like that. I've been, for example, in the Oceanographic Institute, and I was amazed because details, the people don't talk about the text and details and so on, and do more general comments and so on. Here we are a bit more, let's say, sharp.
Yes, too tough with the details, yes. We never know if it's enough or not.
So that's all. We used to take some points in the text and question you and to comment and so on.
Yes, okay.
In the page 11 and page 12, you mentioned wireless ROVs.
Wireless
Mentioned ROVs that can be controlled by optics or radio frequency. Is that true? I can find here the. So, have you ever seen an ROV controlled by radio frequency or optical signal?
By radio frequency, I think I was talking more about the possible modes of communication underwater and the challenges about this, because of course you can use radio frequency to communicate underwater, but because the propagation of the waves is affected, it's not widely used, but it is possible to use radio waves for underwater communication.
I can see here is the section 1.2.
Okay. Okay.
The second paragraph of this section, you say the classification also places too much attention on the mode of communication. Better,
yes.
And wireless.
Yes.
And operation. Okay. So if you say theta for me, it means I will send comments and energy to the ROV.
Yes.
But I can't send comments to the ROV. Of course, only if it's some very sporadic single comment by waves, and usually we use acoustic waves to send something like, in the case of AUV, say, okay, abort the mission. Okay, start to do another kind of a pre-programmed maneuver and use acoustic.
Yes.
In the past, maybe now even in military submarines, in small distance, they use radio frequency for communication on this case. Of course, the electrical engineer know about the impedance of electromagnetic waves.
Yeah.
We can't do that. Nowadays, there are companies, there is only one company, and some oceanographic institutes, one in the US, another in France, and here we develop it as well, that use optical models. Like you can, but you need to be in a small distance, or you need to be operated in very clear waters. And you can have a kind of bandwidth of megabits per second. Okay, but this is a new development. So there is only one company that is selling this kind of thing. But you use that not to control a vehicle. Because if I read your text, I may have this confusion. You don't use to control, to operate. You just use them to transmit data. You don't need to move with the vehicle on a base, connected to something, track data. No, just be close to the receiver, and you go to the transmitter, or there is a transmitter on the ground, and you go to the receiver that is close to your vehicle, your ROV or your AUV, and you get a lot of data. For example, that was collected on the seabed. Okay, there is this optical communication, but just to get a lot of data without using physical connection, material connection. Okay, so when you mentioned wireless, I think okay, but not even radio frequency is not clear. In page 15, you started, I think it's one of the first times you mentioned an autonomous ROV. For me, it's a kind of, as I told you, I'm more maybe practical, have a practical view. If you say autonomous ROV, for me, is a kind of contradiction in terms. Because an ROV, by definition, is a remotely operated vehicle. It can't see autonomy. When the AUV is on surface, I can give to some the past trajectory planning. I want you to go from this geographic coordinates to that, and so on. And you collected this kind of data when the time frame is so on. And it's okay. They are not. If you are going to talk about artificial intelligence point of view, maybe this can be considered an intelligence sophisticated enough vehicle to be called autonomous, but is what we used to distinguish from an ROV, because if you do pre-programmed maneuvers without the interference of the operator, release it and get it.
Pre-programmed.
Sometimes, of course, as I told you about the acoustic communication, after sometimes we send an acoustic signal to tell something to the AUV. It's not usual, even though it's not enough to be considered as a remotely operated vehicle. What we call by a remote operated vehicle as a drone that I'm commanding every time. I'm commanding every time. Okay, I have an interaction with the vehicle along the mission. It's quite different from the AUV.
Okay.
From the untethered vehicle.
I don't know if I should wait for you, or I should. I understand this. Thank you very much for your comments, and I understand that there is the definition of what autonomous underwater vehicle is, and what remotely operated vehicle is. And this is mostly used in the literature, as I have seen also. But in my argument, what I look at is, for example, you mentioned hybrid remotely operated vehicles, and they can operate both as an AUV and as an ROV as well. And the point is, the underwater vehicle can be operated autonomously, as you said. They can be, it can be, some commands can be pre-programmed in it to perform inspections autonomously, or get data, or anything that is needed. But from the way I see it, I think that this has more to do with the modes of operating the unmanned underwater vehicle as a whole?
Who is operating? Who is operating the vehicle?
Yeah, it can be teleoperated, of course, and it can be operated autonomously.
Depends on where you be.
Yeah.
Untethered vehicles. No.
Mm.
There was in the 80s, maybe, a French vehicle called Escola.
Okay.
Have a drop shape. It was the only case I know. They tried to teleoperate an AUV, an untethered vehicle, by acoustics and so on. But there, I know all these examples.
Mm.
I don't think you can find an untethered vehicle that is operated, commanded by the surface.
No, yeah. I don't mean it in the form of somebody operating it. That is why I said modes of operation. But I understand what you mean, and from the way I see it, it's the modes of operation does not necessarily mean somebody controlling it. It's the mode of operation of the vehicle itself. I see it from that perspective, but yeah.
This is your view.
Yes.
If you're in an academy,
Yeah.
you should ground it.
Yes, of course. Yeah.
You should base it on the work of others, and should, okay, we have this, and I will be the new definition of operation, remote, and so on. And that comes to my previous talk.
Yeah.
Is it worth
it?
to expand the energy on this?
Yeah.
Because I think it would be better to expand energy to understand all the technological challenges and so on, to explain to us and to point what is the direction of this development. Okay, but this is up to you. Anyway, I don't know, from an engineering point of view,
Yeah.
maybe from I don't know, cybernetics or AI researcher and so on, this discussion could be could deserve
Attention.
a very big energy and so on. No, it doesn't mean that you can't give attention. No, okay, you can comment this and give your opinion and so on, but grounded on the researchers, on the results that you find in the tendencies, but based on results you find in the literature, for example. Okay.
Thank you.
And I don't, of course, we are in the academy. We are responsible for breaking through the paradigms and so on. Sometimes agree, but I don't know if it's that the point at this phase of your research, at this phase of your career.
Yeah.
It's just it's not dogmatic,
yeah,
and I'm not 100% sure about it. But just comment.
Yeah, thank you very much for the comment.
Okay, I understand 2 pages here, 15 and 17, to comment something that contradiction, I think it seems to me. Of course, I will send this to, it's in Portuguese, probably you have to write it about these comments, you can find them.
Okay.
And so again, today ROVs have advanced. Then they can operate autonomously. This, for me and for the community, sounds
contradictory.
Yeah. And let's see. There are three modes in which ROVs can be operated. You say in section 2.1. Parallel operation, semi-autonomous, and fully autonomous or simply autonomous. Well, okay, where this definition comes from? There is no reference here.
Yes, there is no reference. What I
And you say,
there is no
in
reference. Yeah.
sequence, ROVs are controlled from onboard control rooms on the support vessel. I agree with you 100%. ROVs for me is like this.
Yeah.
They are controlled from control rooms in support vessels. This is the way I understand ROV.
Yes.
But at the same time, in the beginning, you say that they are semi-autonomous and fully autonomous ROV. And so I was saying, I will not extend so much on this topic, but I think maybe you should be careful about this classification and so on. They should be grounded, referenced, and you should be looking at. I think I've seen this in along your text, some contradictions between ROV, AUV definitions. Sometimes you assume the common, as you did in your presentation, the common definition you made that we had from ROV and AUVs. You did that in your presentation.
Yes.
But along your text, sometimes you change from one to other. And for me, it's a bit confusing.
Okay.
I pointed that along the text, okay? And I don't want to bore more the audience. So I will go to another topic here. Another kind of general comment I would like to do is, when you're showing these new things, I would like to see photos, figure, and so on. And the figures you showed are a bit too simple sometimes and a bit confusing for me sometimes. For example, you showed a kind of page 26.
Okay.
You show a classification and equal to the pedestrian underwater vehicles. And I've seen only a picture of that. And in your presentation, you showed a kind of crab robot.
Yes.
I would like to have seen, because for me, it was the first time I saw, for me, there were no pedestrian underwater vehicles at all. It was the first time in my life I saw this kind of robot in your presentation. Why is not in your text?
If you go to page, I don't know. Okay.
I know the figure. There is a figure there.
Yes.
But for me, it's like, okay, he may took that from a science fiction book and so on.
Okay.
I like to see
the photo.
A real thing, a
Okay.
photo as that you show. I want to see photos. The people want to see the real things. Oh, this robot exists, and or to show the reference, but the reference must be grounded on a concrete robot, not imagination, an imaginary robot.
Okay, thank you.
Well, about the technological systems often, ROV. For me, you just mention most of the time, you mention them, and you sometimes you criticize or give a comment on the challenge. But you could collaborate more in the work if you explain. We are engineers, how it works. For example, the TMS, the Data Management
System.
This is a big challenge, you know. It's not a common thing. Maybe Professor Fabricio already had this kind of challenge in order to design a TMS and not to import it. We are at this time we are doing this designing a TMS. It's not a trivial thing, and it would be worth to show us what do you understand, because this is it's a particular device used only mostly on ROVs only.
Yes.
This is an example, okay? We have other systems there, so communication and so on. You see, you mentioned the virtual reality, and
Yes.
to show more how they will use it in the case of ROVs, for example.
Okay.
The photo and
Yeah, I agree. Those paragraphs were short.
Yeah, if you permit just a few small comments. Yes, this is the kind of thing that we always have doubts too, because sometimes we are afraid to explain again things that are already explained in the literature. But in this case, it's clear.
this is the pioneer work.
Yes. Now it's clear. Yeah.
Of course, you don't need to repeat. You're not going to repeat what a textbook does, but you give basic some fundamentals and so on. And don't need to go to all the mathematical details.
Yes, in a more didactic way. Yes.
And okay, I will jump to sorry. In page 32, you mentioned a kind of device called ARMS. But it's just mentioned, and I don't know what it means. This device. What is it?
This ARMS device is it's like a snake-like robot. Yeah, that it doesn't have the body of the ROV. It's just like the arms, like a snake. Yeah, has been proposed by researchers.
It's not that one from Norway.
No.
It's not that one.
No. It's not that one. Actually, this one. It's not that one. I understand. This one is trying to explain because there are some challenges because I mentioned here that there is manipulator-based non-destructive testing technique, and then there is pod-based non-destructive testing techniques. And one of the challenges of the manipulator-based is stability and dexterity. Yeah, so it's very difficult to apply the techniques because of this. So that is why pod-based tools were developed for this. But for some techniques that need to use the manipulator for the inspections, there is some research on this, on the force feedback, to be able to control the movement and make it more stable. That is the reason. So this ARMS is one of those research development. Yeah.
But it was aimed for underwater application.
So for underwater application, yes.
Maybe you could give more details on your case.
Okay.
Because of course this is very common manipulator feedback control on industrial manipulators. But on the water, at least it would deserve a reference picture. So.
Okay.
Okay, and I will jump to chapter 3. And I like it that you put the application of ROV in oil and gas industries. And maybe that's what I told you about the structure of the text. Maybe you could reserve a separate chapter for those technologies. They not mixed with other things.
Okay. Are you referring to chapter 3.13?
Yes, I mean, you present this inspection technologies, the conventional IMR method,
Yes.
things like that. This deserves, I think, separate chapter talking about application about ROV, in my point of view. Because you, in this same chapter, you start to discuss about the new developments of the drone ROV and so on, a resident and so on. I think this would deserve a chapter called the future, the trends, the new trends on this ROV technology.
Okay.
I wouldn't mix with the current technologies of application of ROV.
With
But
the
you're
new.
mixing both in this chapter 3.
Yes. Yeah.
Figure 19. Yeah, I think this figure, for example, I've seen figures like that along your text. There is the figure 19, page 49, INR relationship between concerned parties. I think this is your creation.
Yes, it is.
But, for me, it's not so clear. It's not so comprehensive, I think. The relationship between the figures.
Okay.
The blue one is more, there is a big area inside the red one than the yellow one and so on. And this is how it represents the interaction between those fields. I think should be more explained in the text.
In the text.
It is your creation, so you should give more details than that. So, one thing important is that this is very important. You mentioned a kind of a USP, the unmanned support
Unmanned support platform.
Unmanned support platform. Okay, this is one thing that people are working with. There are some recent projects on this, and but you talk about latency and bandwidth. When you try to comment, you have the vessel, you have the ROV from the vessel, should be launched from that. A minute, go down, do the inspection, come back, be recovered, and so on. And you say that people are controlling it from the shore, from another country, by internet, so on.
Yeah.
So I would like to see more discussion because it doesn't seem an easy task. You talk about the latency and big challenge here in this case. Latency and the bandwidth.
Yeah.
Can you imagine you're an electrical engineer? How do you control in a very good bandwidth, for example, in millisecond sample time? From here, USP, and you are there in Santos or on the north coast of São Paulo. I want to control my ROV.
Yeah.
What do you think about this test?
Yeah, there is a challenge on that, and That is why I said that the challenge is latency, signal latency. And it might be one.
They have solved this problem.
No, they haven't solved the problem. And I think in my comparison, I considered this in the table. In the table that I did at the last part, of where I compared the methods, the 4 methods that I identified, because I used the pros and cons of each method for the comparison. So I think I did not mention here that the challenge of latency.
Challenge,
yeah,
but,
challenge. Yeah,
they are already, but there are. I know that there are some companies already which are launching some systems like this. Actually, in Brazil now there is a company which is launching this kind of. They have already the ASV and the ROV. It's launched from the ASV, and I know that already there are companies, Teledyne, for example, I think they sell you the ASV together with
as a system. Yeah.
So maybe it could present something, and because they could progress. That is a challenge, but they could progress this.
Thank you.
There is one thing also. So you showed in your presentation as well. Is yeah. In figure 23, I think you showed the figure 23 in your presentation. Resident ROV system configuration.
I did not show this in my presentation.
You didn't? I think I've seen that. Okay.
I showed. If you look at, I showed the figure 22 in my presentation.
Okay.
I did not show the configuration.
Okay. In the figure, figure 23, you show different resident ROV system configuration.
Yes.
Okay? How about this D configuration? For me, this is not a resident ROV. Please look at it.
D.
Yeah. Everything comes from the floating platform. This is for me is a conventional type ROV operation. It's not resident. For me, a resident ROV, it means it stays in the sea, on the seabed, on a platform, docking station, as you call it. And from time to time, it wakes up and do some task.
Yes.
And goes back to the docking station on the seabed.
On the seabed, yeah.
Your deconfiguration. Your deconfiguration, you have a direct
docking station on top, on the
docking
platform.
station on top. It's not the resident. The resident is on the surface.
Yes.
But I think this is a kind of resident ROV because it can be the people can go there and in the floating platform and control your ROV. It's not on the seabed. For me, it was something different.
Different, yes. I understand what you mean, and you are right. Because this one, if you see, I took it from a reference discussed that a paper that was discussing about resident ROVs. Yeah, so the error is from him, and from my part, I did not see this. Thank you very much. Yeah,
it may the person
I agree with you. Yeah.
Talk for it's a resident ROV, but the resident on the surface.
Yes. Yes.
That this platform should be there forever on the surface. And
yeah, this D part is more like a fixed traditional method of conventional method of conducting inspections. Yeah.
And that's in all the times I saw here, there is this platform. There is a floating platform in all your figures, A, B, C, D. Okay, and if you consider ROV, an AUV as an ROV as B, there are other configurations where the vehicle, the EUV, and the EUV, is on the docking station on the seabed, and from time to time it wakes up, does some work, and comes back. In the 90s, I've seen a presentation from Woods Hole Institute. They started with this AV. It was a kind of enterprise, Star Trek Enterprise shape. AV was in a docking station. From time to time, when there was an earthquake or something, geological phenomena, the AUV was started, triggered, and did some tasks and came back. Recently, Brazilians from Salvador, they developed actually with people from Europe, the flatfish that has the same kind of behavior.
Yeah.
But it's applied to offshore or an oil industry, oil and gas industry. And these are to be our resident type AUVs.
Yeah.
Since you consider sometimes these as RV, they should, and in those cases, you don't need a surface platform.
Yes. Yes.
Yes. If you permit to mention, yes, it's a very important part of your work, because there is a confusion in the literature, really. So it's hard to make this confusion more clear, and it's part of your work. So it's good to work on that. Very well.
Okay. And you say, I'd like to ask you, you say that the resident mode is the most reliable one. Why do you think so? Compared to the others?
Yeah, compared to the others, because, for example, if you compare it with the traditional method, there is a very low response time because of the process. Of course, you would need to hire the subsea contractor who is going to do this job, and they need to come for inspections. And this takes time. The mobilization process, the demobilization process, this reduces the reliability on this type of inspection method. But if the ROV is resident in the vicinity of the offshore assets, it can serve as a monitoring tool as a whole to monitor the subsea assets. But of course, it will have a large initial investment capital, but over the long run, it is the most reliable approach for inspecting offshore assets.
Because maybe you're talking about the economical point of view.
Yeah.
But when you say reliability, from the technological point of view, do you think it's more reliable to have a vehicle a long time resident on the seabed?
Yeah, I think so, because the equipments, usually the problem comes with the equipments, which is tied to also the technical capabilities of the ROVs. But resident ROVs also have in store equipments that are needed for the inspection, maintenance, and repair operations all the time, and this can be replaced as they are being used over time. And when it comes to the onshore control as well, they don't necessarily need to be offshore. There can be some few ROV crews who are always present in the platform for this purpose.
But do you think the operation will be reliable because of this latency problem, distance problem?
The latency problem. Yeah, if the control room is situated offshore, of course, this latency problem must be taken into account. But if the control room itself is situated on the platform, I think this will not be much of a problem.
Okay.
Yeah.
Well,
It all depends on the approach.
okay, I have more details, but they are written here, and I can give you later on. And I'd like to congratulate your work and your report.
Thank you very much.
I hope we can proceed your research on this.
Thank you very much. I highly appreciate and also thank you very much, Professor Fabrizio, for your comments. And I have written it here, and I'm going to consider your suggestion. Thank you so much.
Well, thank you so much, Professor Ettore. A lot of information. I took notes of as much as I could, and also Abba did. And we have a lot of work, I'm sure. Anyway, is a field of study that we are very much interested. So we need to work hard on these comments and improve, even for the next works and next people working on that. So thank you very much. It's very important. Well, now I have very few comments because, as you know, I have been accompanying all the work since the beginning. So most of my comments I have done during the work, and it's already inside the work with the problems and everything that was mentioned. So what I could just mention, I think it's interesting to mention, is that this work is one more work that is part of this crazy moment that we all lived during the pandemic, when we started with some objectives and planning some practical activities. Then we have to move to other different approaches because of the pandemic. So it was a challenge. I understand that, and I see, and now I see even better that this challenge is even bigger than we could imagine. A lot of details that we still have to address. Another point is when you mentioned the confusion between the names ROV and AUV. Yes, I understand now that it's something that we need to study more in order to find some improvements in this classification still. Because I think the initial idea was to simplify the confusion of names. We have so many names and so many different definitions of the same thing in the literature that we maybe in this moment Abba said, and it was really a doubt for every one of us, that we could concentrate everything under the same name, but not always this is possible unless we try to find another name that could include both ROVs and AUVs. So it's something that we can propose, but it's also complex because we need to deal with the culture of the world that is so accustomed to this kind of definitions. So this is important for us to keep analyzing. I think this is the most important points I like to mention. I don't know if anybody else wants to say anything. You also our observers. If you want to ask something, you are also allowed. No? Okay. So thank you very much. I think now we need, during this process, we need you to leave for a moment when we will have a discussion here with the members of the committee. And then when you leave, please close the door. And then we call you back when we finish. Se vocês quiserem tomar um café, fica à vontade, viu, Fabrício? Eu não sei se você está à vontade para continuar, você quer parar um pouquinho?
Não, sem problema, professor, está tranquilo aqui.
Bom, como eu comentei aqui em inglês, né, foi um desafio grande para a gente, né, essa situação. Desde quando o Abba chegou, né, muitas coisas aconteceram, muitos planos mudaram, né? A gente tentou fazer uma coisa mais prática no início, tinha até aquele rolê que o professor Ettore viu aqui, e eu não sei, acho que a gente mostrou pelo menos algumas fotos aí para o Fabrício. A gente tentou levar para campo, tentou fazer alguns ensaios e discutir com a indústria também, ter algumas atividades mais práticas, isso ficou comprometido. Então, a gente teve realmente essa particularidade aí, que pode ter comprometido o trabalho. Mas eu queria agora ouvir de vocês a opinião geral, o que vocês acharam. É lógico que existem várias coisas aqui importantes que precisam ser corrigidas. Agora, cabe à banca definir. A gente tem aqui o modelo da nossa... Eu mandei para vocês, né? Eu vou até abrir aqui.
A ata, você não tem?
Da ata. Eu só não imprimi porque eu pensei, como a gente vai mandar, como o Fabrício vai fazer e vai mandar por e-mail para a gente.
Eu gostaria de assinar, deixar contigo. Você pode
tá.
Digitalizar, mandar para ele. Eu fiz isso dia.
Então, não tem problema nenhum.
O professor que estava fora também.
Não tem problema nenhum.
Porque eu não tenho assinatura.
Tranquilo. Eu imprimo agora mesmo. Eu só vou abrir aqui para facilitar. Só um minutinho aqui. Deixa eu achar onde eu coloquei. Acho que é mais fácil achar no e-mail. Aqui. A ata da defesa. Então, a nossa resposta tem que ser seguindo essas instruções aqui da ata, né? Então, tem aqui o nome do candidato, o Abba, 5 dias do mês de maio, realizou a defesa da dissertação, aqui tem o título, eles colocaram em português, isso veio da secretaria. Após a declarada aberta a sessão, o senhor presidente passa a palavra ao candidato, como a gente fez, em seguida as devidas arguições, seguindo o formato padrão, em seguida a comissão julgadora proclama o resultado. Quer dizer, é lógico que a gente pode fazer alguns comentários aqui, discutir, mas o resultado final é simplesmente aprovado ou reprovado. Então é isso que vai constar na ata, né? E são 3 resultados diferentes e funciona assim. Por exemplo, só para esclarecer, acho que talvez todos vocês já estão acostumados com essas defesas, mas só por formalidade, né, tem que esclarecer que funciona assim. Então, por exemplo, se tiver 2 votos aprovados e 1 reprovado, ele fica aprovado por 2-1. Se tiver 2 votos reprovados e 1 aprovado, ele fica reprovado por 2-1. Independente de quem aprovou ou reprovou. Simplesmente são 3 votos e a decisão da maioria é a decisão que fica valendo. Obviamente, qualquer membro da banca que tiver interesse em fazer algum comentário adicional, quiser colocar algum comentário adicional, pode fazer também, embora aqui, por acaso, nesse formato aqui não tem espaço para isso, mas em outros, acho que não sei se eles mudaram, em outros formatos eu já vi espaço para colocar. E nada impede de vocês colocarem, se quiserem também. E a gente coloca, nem que seja no anexo. Tá? Mas, de qualquer jeito, fiquem à vontade para falar. Não sei se vocês têm alguma opinião. Quem gostaria de começar aí? Fazer algum comentário, o que acharam? Em geral, do trabalho, né? A gente está à vontade aqui para discutir. Fabrício?
Professor, assim, eu não sei se o professor Ettore, ele teve a oportunidade de ver o trabalho dele da qualificação, né? E em relação a esse que ele apresentou, a evolução foi muito muito grande mesmo, né? Percebe aqui que ele foi bem orientado, né? Considerando os apontamentos que o professor Ettore fez, todos pertinentes, né? Por vezes aqui ele faz algumas comparações, principalmente em relação ao controle wireless, né? Logo no começo ele coloca que é algo que é assim, impraticável, por isso aqui você não vê mesmo controle wireless, né, de equipamentos remotamente controlados, mas depois ele classifica, né, o dispositivo como, olha, tem alguns que são wireless e outros não são. Então tem algumas coisas mesmo que poderiam ser melhor apuradas, mas eu acho que vendo assim, a evolução do Abba como um pesquisador, isso é perceptível. Ele defendeu bem, inclusive, né, algumas questões aí que o professor Ettore colocou. Então, eu acho que o trabalho está maduro o suficiente e não voto pela aprovação.
Legal, obrigado. Fabrício, só aproveitando para fazer um comentário, então, sobre essa questão do wireless, né? Eu lembro que, numa época, a gente chegou a... Quer dizer, ele, né? Ele foi atrás de uma empresa, se não me engano, até uma empresa lá da África mesmo, que por algum contato que ele já tinha lá, ele achou uma empresa que estava tentando desenvolver alguma coisa nessa linha. Então, acho que talvez ele se apegou a isso, né? A essa empresa que tinha...
Eu não sei se o professor Ettore já teve contato, mas assim, o que eu percebi de fato é um desafio. A latência e tal. Em geral, esse tipo de inspeção que ele está propondo aqui é bem complexa, né? Inclusive, ele coloca aqui, que o professor Ettore comentou também, né, daquele ARMS, né, que é aquele sistema que você tem um feedback, né? Parece aqueles controles novos de videogame que você tem aquele feedback áptico, porque às vezes a imagem que você está tendo lá debaixo d'água não é o suficiente para você perceber se ele encostou ali na peça, não encostou. Então, aquele feedback áptico, ele permite complementar a imagem, olha, encostei aqui, né? Então, as operações são muito complexas. Nesse sentido, você fazer isso, né, por meio de um meio de comunicação que tem uma latência grande, né, e que a banda não comporta assim um grande número de informações ou a amostragem de sinal ali não permite que você, né, tenha um feedback e um envio do sinal suficiente para que você conduza operações que são muito precisas. Fica complicado mesmo, mas eu já vi algumas pesquisas, né, que funcionam mais ou menos como você controlar uma sonda fora do planeta. Você manda os parâmetros, né, e aguarda o feedback ali, tem que ser uma coisa bem precisa mesmo, bem devagar. Então, por meio de ondas acústicas, isso é armazenado em um buffer dentro do microcontrolador ali, ele faz aquela operação e você aguarda para ter o feedback. Então, você vai fazendo as coisas bem devagar, mas depende do tipo de operação. Conduzir uma inspeção muito complexa, né, isso demoraria uma eternidade, mas existem iniciativas nesse sentido. Mas, como o professor Ettore colocou, assim, não é comum, você não vê sistemas remotamente controlados por wireless, né? Todos são via Tether, então de fato o sistema predominante aí.
Uhum. A não ser que seja alguma coisa complementar, né? Como o próprio professor Ettore comentou, se for uma coisa muito simples, né? Que possa ser um backup ou uma coisa a mais, né? Talvez, né? Bom, professor.
Bom, eu acho que eu acompanho aí o relator. O trabalho tem esse mérito para nós aí, de produzir essa análise mais ampla. Nós, pessoal da África, uma das primeiras. Vocês costumam orientar alunos? Ele é um dos primeiros?
A gente fez um acordo, eu até aproveito para mencionar, tinha até um outro aluno da África que veio nesse mesmo acordo. A gente fez um acordo com o PTDF, que é uma fundação nigeriana voltada para apoiar pesquisas na área de petróleo. Mas que ela cresceu, mais ou menos como a ANP faz aqui no Brasil, mas ela cresceu e acaba apoiando alunos até em outras áreas também. E aí ela fez um acordo com a gente, foi por volta de 2016, pelo que eu me recordo, e aí nesse acordo vieram vários alunos, né? E aí foram vindo, alguns chegaram depois e tal, e o Abba foi um dos que chegou nessa linha. Então, ele se interessou, ele gostou muito, alguns deu mais certo, outros não, outros acabaram mudando de área, mas o Abba foi um dos que gostou de ir até o fim, tanto que ele citou aqui, né, que ele pretende continuar, inclusive, no doutorado. Ele até já prestou o processo seletivo aqui, ele nem comentou, já foi aprovado no processo seletivo, só que ele não pôde ainda se registrar por conta de que ele não tinha terminado esse trabalho, né? Mas, então, ele tem interesse em continuar nessa área. E a gente já tinha feito alguma coisa no nível da graduação, até junto com o Fabrício, né? A gente tinha até um trabalho de extensão. Isso aí eu até aproveito para comentar para você, viu, Fabrício? A gente teve algumas lições aprendidas nisso, porque tem muitos projetos de extensão com os alunos, né? Só que o aluno tem uma certa autonomia para fazer esses projetos, né? Amigos da Poli, que apoia e tal. E a gente perdeu, eu senti que eu perdi um pouco o controle da situação. Chega uma hora que os alunos, entre aspas, crescem tanto, né, naquela empolgação de fazer aquele trabalho, e eles têm uma certa independência mesmo, né, porque o objetivo da extensão é esse, dar um certo protagonismo para os alunos, né. E a gente começou a discordar, né, e começou a ficar difícil, começou a gerar ruídos. Da atividade de extensão. De repente, o aluno se sentiu mais dono do projeto do que quem estava orientando. Né?
Então, isso unido à falta de experiência deles a realizar projetos, professor, de fato tem o potencial, às vezes, de deixar a coisa meio difusa. No caso específico do que a gente desenvolveu junto, né, o escopo deles ficou muito grande. Eles queriam fazer o mundo, né? E eu falei, gente, vamos desenvolver o protótipo, né? Colocar ele na água, comandar, e depois a gente pensa em colocar a sensorização, os manipuladores. Eles já pensaram em fazer tudo, né? E dentro do escopo que a gente cortou ali, a gente conseguiu evoluir bem.
Sim, sim. Então, eu acho que é isso. Só respondendo então para o Héctor, a gente começou no nível de graduação, mas o ABA é realmente o primeiro no nível de pós-graduação. E a gente espera aí futuramente, né, ter mais, inclusive no nível de doutorado também. E, inclusive, né, a gente espera a oportunidade até de trocar algumas figurinhas aí com você ou com outros pesquisadores aí da mecânica ou mecatrônica também.
Bom, então, acho que está se iniciando uma cooperação, a gente está recebendo um aluno aqui. O mestrado serve, do meu ponto de vista, muitas vezes para tirar alguns buracos da formação da graduação, né? Agora, eu acredito que, no caso de um doutorado, o buraco é muito mais embaixo.
Sim, com certeza.
Você precisa ter uma fundamentação muito mais forte, você precisa provar as coisas que você afirma. Isso é uma coisa que já tem que começar a aprender no mestrado. E aí o teor tecnológico também da coisa tem que crescer, porque, basicamente, esse trabalho ele fez um levantamento bibliográfico e uma crítica disso, né? Levantamento bibliográfico. Acho que doutorado, acho que a contribuição dele vai ter que ser mais.
Com certeza. Inclusive,
né?
até por isso a gente fez uma parceria, uma pré-parceria aí com uma empresa grande aí do setor de ROVs, a Constellation, não sei se você conhece. Ela atua aqui no Brasil, principalmente na área de óleo e gás. Fornecendo, acho que ela fornece equipamentos de terceiros, a gente ainda precisa discutir melhor com eles o escopo disso. Mas é uma empresa grande que tem os ROVs, né, e já se disponibilizou a cooperar. Então, a ideia é a gente tentar propor soluções que envolvam a mineração subaquática, né? Mas aí já com um viés mais prático, aí com o ROV de verdade e tal, né? Mas é isso, talvez até a gente possa conversar mais futuramente sobre essas possibilidades.
Bom, isso.
Bom,
Pode também, então, aprovar o aluno. Tá? Acho que eu passo para vocês aí a minha observação sobre o texto, talvez encaminhar alguma revisão.
Ok, então, muito obrigado, então, professor Fabrício, muito obrigado, professor Ettore. Eu vou imprimir aqui. O Fabrício já tem aí a ata, né, professor? Então, você pode mandar para a gente assinado. E
a gente assina os dois, aí você digitaliza, manda
melhor.
para ele, aí ele bota a parte dele, manda para cá e você manda para cá. CPG aí.
Melhor, boa ideia, bem observado. Eu vou imprimir agora, a secretaria está aqui embaixo, eu já vou pegar em 1 minuto. Deixa eu colocar aqui, depois eu... E eu não sei se eu já posso chamar ele aqui, ou é melhor eu trazer primeiro? Acho que é melhor trazer primeiro a folha, né? Só para...
A gente já deixa o nosso.
Deixa eu pegar aqui. Agora você deve estar com calor, né? Acho que eu pode até ligar de novo aqui. Acho que o Abba desligou porque estava com muito ruído. E o som não estava muito alto. Mas eu vou ligar de novo. Deixa eu ver se melhor eu assinar primeiro como presidente. Nome dos participantes. Ricardo Cabral de Azevedo, vou colocar aqui. Vou pedir, tá, para ele assinar esse outro papel da edição revisada, onde ele vai colocar todas as observações, tá? Vou até escrever aqui. Ele tem um prazo de 60 dias para fazer isso. Eu não sei onde é que a gente... é aqui embaixo que a gente assina. Claro. Já vou assinar esse daqui também. Esse aqui é um compromisso do candidato com o presidente. Tá, só para mostrar aqui para o Fabrício, então, a gente já tem as nossas 2 assinaturas nesse documento da ata, tá? Eu vou escanear e vou mandar para você.
Senhor, manda, já te devolvo imediatamente.
Sim, além de assinar, você tem que escrever aqui, né, o resultado, né, se você está de acordo, colocar aprovado. Né?
Tudo bem.
Posso chamar ele, então?
Claro.
Então tá. Chamar. Pronto, pessoal, podem. Bom, então, eu vou ler aqui rapidamente a ata, baseado aqui nas informações, nas discussões. A gente fez aqui uma longa discussão sobre o trabalho, sobre as observações que foram feitas. Então, essa é a ata de defesa de dissertação do senhor Abdullahi Dalhatu, no programa Dalhatu, no programa Engenharia Mineral da Escola Politécnica da Universidade de São Paulo. Então, aos 5 dias... obrigado. Aos 5 dias do mês de maio de 2023, realizou-se a defesa de dissertação do senhor Abdullahi Abba Dalhatu, apresentada para a obtenção do título de mestre, intitulada Estudo e Análise de Inspeções por Veículos Operados Remotamente nas Estruturas Offshore de Óleo e Gás. Após declarada aberta a sessão, o senhor presidente passa a palavra ao candidato para exposição e a seguir aos examinadores para as devidas arguições que se desenvolvem nos termos regimentais. Em seguida, a comissão julgadora proclama o resultado. Então, Ricardo Cabral de Azevedo, presidente, eu, aprovado. Héctor Apolônio de Barros, professor Héctor, aprovado. Fabrício Ramos da Fonseca, Senai, titular também, aprovado. Então, resultado final, aprovado, Abba, você está de parabéns.
Tá, muito obrigado.
Mas,
Um abraço. Muito obrigado.
Obrigado. Mas só lembrando, tá, que isso aqui tudo é mediante a apresentação de uma versão revisada, então eu peço que você assine, você tem um prazo de 60 dias para apresentar a edição revisada, baseado em todos os comentários que foram feitos. A gente tomou nota, acho que você tomou nota também, né?
Mas eu mando por e-mail.
Ah, maravilha, então. Obrigado, professor Héctor. Fabrício, se tiver algum comentário que quiser mandar por e-mail também.
Tá, quero parabenizar o Abba, viu, Abba? Meus parabéns aí.
Muito obrigado, professor Fabrício. Eu agradeço muito. Sim.
Um prazer. O professor Ricardo falou que você ingressou no doutorado, né? Já está aprovado aí. E meus votos que você continue suas pesquisas, né? Porque você, como pesquisador, a gente, durante esse breve período que a gente te avaliou, a gente percebeu o seu amadurecimento, tá bom? Então, meus parabéns, meus votos de sucesso.
Muito obrigado. Boa fim de semana para você. Obrigado.
Você também.
Bom, Fabrício, foi um prazer.
Um prazer, viu?
Tudo bom. Prazer, Fabrício. Então, eu já
estou Obrigado.
Qualquer novidade você me fala, tá? Se tiver alguma dúvida.
Tudo bem. Aguarda a ata aí. Um abraço.
Espera um pouquinho. A gente vai tirar uma foto. Será que dá para o Fabrício aparecer na foto? Ele vai aparecer aqui. Vai aparecer aqui.